Given a random variable x, the pth percentile of x is the number Cp defined as follows. So let AB be an interval such that for every point C in AB, the probability x is less than or equal to C is bigger than or equal to P, and the probability that x is bigger than or equal to C is bigger than or equal to 1 minus P. Then linearly interpolate over the interval AB. So Cp equals 1 minus P times A plus P times B, where A and B are the endpoints of the interval. If there's only one point, so we don't really have an interval, then Cp is just the one point, such that the probability x is less than or equal to Cp is bigger than or equal to P, and the probability x is bigger than or equal to Cp is bigger than or equal to 1 minus P. The 50th percentile is called the median. It's a special case. The 25th percentile is called the first quartile. The 50th percentile is also sometimes called the second quartile. So the second quartile and the median are the same thing. And the 75th percentile is called the third quartile. So let's do a couple of examples. If x is uniform on the discrete set 3, 5, 8, and 9, let's find the median and the first quartile of x. So for any value c in the closed interval from 5 to 8, the probability x is less than or equal to c as a half, and the probability x is greater than or equal to c as a half. So the median of x is 1/2 times 5 plus 1/2 times 8, which equals 6.5. This example is similar to what you're used to seeing in statistics, where we have 4 data points, 3, 5, 8, and 9, and we find the median by putting them in order, and then if there's one point exactly in the middle, it's that point. And if there's 2 points that are in the middle, then we take the average, 1/2 times 5 plus 8. So to find the first quartile, notice that for any c in the interval from 3 to 5, the probability x is less than or equal to c is bigger than or equal to 1/4, and the probability x is bigger than or equal to c is also bigger than or equal to 3/4. So the first quartile of x is, we linearly interpolate between 3 and 5, and get 3/4 times 3 plus 1/4 times 5, which is 3.5. And notice this is a little closer to 3 because we're looking at the first quartile, which is less than a half. So it shouldn't be exactly 1/2 between 3 and 5, which would be 4. It's a little closer to the 3, since it's a lower percentage than 50%. Next, we'll look at the geometric distribution with parameter 0.2. We want to find the quartiles of the distribution x. So the first quartile, or C25, which is for 25%, can be represented by following, can be found by following the sum from 1 to C25 of 0.8 to the I minus 1 times 0.2 equals 0.25. So this 0.25 is the 25%. And we add up the PMF from 1 to some number C25 that we need to solve for until we get 25%. So using a result from calculus, we can rewrite the sum. And so we're going to pull out the 0.2 and the 0.8 to the minus 1. And when we pull those out, we get a 0.25. And that leaves inside the 0.8 to the I. So we'll have a 0.8 to the I inside the sum. Then we use the fact that the sum from 1 to n of r to the I is equal to r times the quantity 1 minus r to the n all over 1 minus r. And that's more of a calculus fact, like I said, so we'll show that in the calculus lesson. Plugging in C25 then for 0 for n and 0.8 for r, we get 0.8 times 1 minus 0.8 to the C25 over 1 minus 0.8. And whenever we multiply this by the 0.25 out front, we get 1 minus 0.8 to the C25. So we want to solve 1 minus 0.8 to the C25 equals 0.25. And doing that algebraically, we get C25 is natural log of 0.75 over natural log of 0.8, which is approximately 1.29. Now, x is a discrete random variable. So whenever you get a number like this and it doesn't include any values that are actually possible values that x could be, you take the ceiling. And that's the general rule for a discrete random variable. So whenever we take the ceiling, we get 2. And you can check that the probability x is less than or equal to 2 is 0.36, which is bigger than 0.25, and the probability x is bigger than or equal to 2 is 0.8, which is bigger than 0.75. So C2 is the first quartile. Now to find the second quartile, or median, we can go ahead and start with the algebra that we did in the previous example. So we can go ahead and start with 1 minus 0.8 to the C50 equals 0.5. So this can be solved to yield C50 equals ln 0.5 over ln 0.8, which is approximately 3.11. And once again, taking the ceiling, we get the median is 4. So the probability x is less than or equal to 4 is 0.5904, which is bigger than a half, or bigger than 0.5. And the probability x is bigger than or equal to 4 is 0.512, which is also bigger than or equal to 0.5. So half the distribution is above 4, including 4, and half the distribution is below 4, including 4. And finally, we can do that for the third quartile. Again, using the algebra we've done above, we get 1 minus 0.8 to the C75 equals 0.75, and solve to get ln of 0.25 over ln of 0.8, which is approximately 6.21. And taking the ceiling, we get C75, or the third quartile, is 7. So the probability x is less than or equal to 7 is about 0.79, which is bigger than 0.75. And the probability x is bigger than or equal to 7 is about 0.26, which is bigger than 0.25. Now let's do an example for a continuous distribution. Let's let x be a continuous random variable with PDF f of x equals 2 minus 2x for 0 less than x less than 1. We want to find the median and the 10th percentile. So the median is the number C50, such that when we integrate from 0 to C50 of the PDF, 2 minus 2x dx, we get 0.5. So we're trying to solve for this number here in the integral. And taking the integral, we get 2c50 minus c50 squared equals 0.5. So we can use the quadratic formula and find that c50 is roughly 1 minus square root 2 over 2, which is about 0.29. And since this is a continuous random variable, you don't round to that or find the ceiling of it. It's exactly 0.29. So x has a 1/2 probability of being less than what's actually 1 minus root 2 over 2, but roughly 0.29, and a 1/2 probability of being greater than 0.29. And to find the 10th percentile, you do the same thing. You integrate from 0 to some number C10 we must solve for of the PDF, 2 minus 2x dx. But since we're looking at the 10th percentile, we want this to equal 0.1. So taking the integral, we get 2c10 minus c10 squared equals 0.1. And use the quadratic formula to solve. C10 equals 1 minus 3 over square root 10, which is approximately 0.05. So x has roughly a 10% chance of being less than 0.05 and a 90% chance of being greater than 0.05.